Hello. Hi. Wait, there we go. There's Adama. Hello. All right, welcome. Why don't we get started? So, looks like we have a couple people here. Maybe we'll get a few more. Actually, I met with Adama yesterday about GSoC. So we have, she wants to work on a project on virtual reality. And in the meeting today, I'll go over some of the pathways to success for proposals. Hopefully that's useful to people more generally, no matter what proposal we're working on. So we'll do that. Looks like Morgan's here. Hello.
Good morning.
Good morning. So, all right. So this week we had, I think we had one meeting, which was DevoWorm, and that was pretty good. We didn't do our Cognition Futures meeting. I think there was a little, I think maybe Jesse and Amanda may have met like for 30 minutes. And then, I met privately with some people on some mentorship points, some Google Summer Code points, and so forth. So, pretty good. Yeah. So, does anyone do you want to give an update or?
I don't really have too much of an update. Jesse and I did meet, and Morgan, for half an hour, 45 minutes.
Okay.
On Wednesday, and just talked about general, our general interest in what we want out of the Cognition Features reading group. I don't think there was anything too new, no new developments, but it was a nice chat. And we did take some notes. And then, we didn't meet for the cybernetics group, but we'll meet next week. And also next week, I won't be able to meet for Cognition Futures.
Okay. All right. Yeah, that sounds good. Yeah, we're rolling along on that. Right now, we're reading the paper. I think it's allostasis and interoception, basically. Can't remember the exact title, but it's a good paper, and then we have long-term goals as well, so that should be good. Plotting those out, and then of course the cybernetics group, which we've been covering a number of papers. We did the 11 paper. We did, I think, 2 11 papers, and then we shifted to Maturana, and I guess we want to shift back to 11 maybe for this next meeting. So, I mean, it's up to us what we want to do, but keeping within our themes. So, hello, Sarrah.
Hello. Good morning.
Good morning. One of the things I wanted to talk about today was so some of you are applying for Google Summer of Code, and the people in the meeting, and some of the people watching this on YouTube, where we have people can't make the meeting, whatever. But this is good advice across, not just for Google Summer of Code projects, but for a number of projects, any kind of project management you're doing, funding proposals, whatever. It's a similar kind of outline. So I'm going to go over kind of how do you structure a proposal when you want to answer a call that someone puts out. So basically what we've done is we put out calls for projects. That's if you've read through the NeuroStars posting for each project, then you know that this is like a call that we're basically making a call for involvement. These are the things we're interested in. So with the VR project and XR project, we have like 3 possible areas, and you can be flexible within that. So it's basically just saying, here are the things that we're interested in. If you want to propose something else, that's fine, but it has to be kind of within the scope of this area. So, it just kind of frames everything for people. And then, but then it's not just enough just to say, I want to do X, Y, and Z. You have to structure it a certain way. So the first thing, the first path is, of course, sort of getting sort of involved, understanding kind of where you are in this project. So, and I think for the two projects sponsored by Orthogonal Lab, that's I think 5.1 and 5.2. You want to understand kind of because these are projects that have been listed in previous years. So you want to understand where those projects have been and where they're going. So for 5.1, for example, which is the VRXR project, we have a repository of work from last year. So that work is, I have a link to it. I think I put it on the GitHub, in the GitHub repository README for GSoC. So that is for people to read over. So it's a Zenodo link, and it goes to this repository which you can download. And it's just all the files from last year's work. So Vrushali Nandurkar worked on this project last year. She generated basically what amounts to a virtual lab. So that virtual lab has a lot of assets in it. And so you can use those and improve upon them. Or you can basically create your own project. You can say, create a project around the OpenWorm browser, or you can create a project around a psychology experiment, depending on your interests. And so, we can that's the kind of project we'd like to do. For 5.2, we have this white paper on open source sustainability, which is on ResearchGate, and I showed it last week. You can look at it. It hasn't been updated to reflect last year's contributions. It's something, we've been meaning to do over the break between GSoCs, but we didn't get a chance to do it yet. So this will probably be something that'll come maybe during GSoC, and then, whoever is selected for that project, they'll get to contribute to the authorship on that, and we'll update it accordingly. And so that white paper lays out the rationale for why we're doing that project, the 3 models that we have, and then, I think there may be some, what needs to be updated is basically refining the models, refining the hosting, and, since we don't really have a really good hosting solution for it right now, it's a little hard to, specify in the white paper. I think another thing that needs to go in that white paper is sort of how do we create measures of sustainability in it. That's something that hasn't really been discussed in that paper. So, and I mean by that, I mean having a discussion about sort of how do you, create a measure of sustainability, maybe what are some potential candidate measures and so forth. So that'll be updated, in the next, over the season. So the second path to success here is writing a proposal. And writing a proposal is, not as easy as it sounds. So when we write a proposal, we're usually responding to a call, like I said. But there are 2 parts of this proposal that, for GSoC, that are really important to get straight. So number 1 is the outline of your basic idea. So I want, people to sort of have a coherent sort of presentation of what they want to do and how does it fit into what's been done. So, when we propose something in a call, it's usually like, okay, we want to do these things. You can do a number of things within a range of possibilities, and you're trying to make an argument for what you want to do as being the best use of resources. So if I have like I want to make assets for, say, like to make a learning and memory experiment. I'll have to learn about the experiment a little bit and know kind of how it operates, the logic behind the experiment. Then I want to create the assets and then I want to create like the timing and everything. So you want to really understand kind of what you're doing and how you make decisions. So that's important. And sometimes in proposals, I like to see where people have already taken a start and maybe like, done some maybe done some preliminary coding or, some preliminary planning for their project. So in some years past, we've had people who have taken some data and run, some algorithms like, some sort of RNN on some microscopy data and gotten some results. And then they're making the argument that I'm going to do these things and I'm going to improve this performance on this thing. But they just maybe include some screenshots that show how, they've implemented something very simple that they can get an output and that this was maybe what it'll look like. But, the thing to remember is you don't need to do all the work for the proposal. You just need to show that you may be able to do it, that you can do a good job, and that you know what you're wanting to do. Now that leads to the second point, which is a schedule. So a schedule is very important because it basically constrains you in terms of your resources. So what I mean by that is that you only have a certain amount of time to do this over the summer. So it's not like an open-ended project where I'm going to do as much as I can do, and then maybe we'll stop at some point. You have like maybe 12 weeks realistically, and in 12 weeks you can't do everything. In fact, you may just be able to get started on something. Now, if you pick something very hard to implement, that's going to impact what you can actually do. So you may not even be able to really get anything analyzed. You might just be able to set up the code and just write some code. So that's all you can do. So that has to be reflected in your schedule. So your schedule should be, a weekly account of what you're going to do. And so this is like, week by week. And, each week you'll say, this is what I plan to do. This is what I might do if I can't do the thing that I planned as my first priority. And then maybe have some weeks in there where they're free, where you can kind of move your schedule around. So, getting these chunks here, getting those right is the challenge here. Saying how much work can I do in a week? And how much work can I do over 12 weeks? And is that going to be like something I can turn into the program and say I passed? Because what they want to see is they want to see something coherent come out of the project. They want to see some code. They want to be able to run it ideally. And in recent years, they've sort of said, you can go beyond code a little bit. Like you can work on some documentation or whatever, but it has to be something coherent. It can't just be I did a little bit of noodling around with some code and here it is. And that's not like necessarily useful for the organization. So, we want to make it useful at least as a starting point or an improvement to something in the organization. So that's the other thing you want to keep in mind is the schedule needs to be relevant to the organization. You want to get to sort of maybe a stopping point, but something that, is useful, someone else can pick up and use. So like last summer for the XR project, Vrushali created a number of assets. There, a number of different scenes. That's a good starting point for another project. That's just where that's what kind of a stopping point you would look at. Or like implementing one model, for like open source sustainability. Just implementing a model. It doesn't have to be perfect. It just needs to be like, to some degree of where you can demonstrate it and, have people see it. So a demo is basically the target. So then the question is, well, what happens if you try really hard to be educated about this, but you still run into problems? And so what we can do and oftentimes this happens, is we can rescope the project. So we can take this schedule, and it's important to have the schedule in place, because what we can do if you run into problems is we can rescope parts of the schedule. So we can say you get up to like week 8 and you find out that, okay, well, I have 2 candidate approaches, one works and one doesn't. So I really need to kind of just go forward with this one approach. And that'll affect what I said in my schedule. I said that I could do these things, but I can't really do them because this part of the project didn't work out. Well, at that point, we would, of course, be in weekly communication at the very least. So we would have like this constant back and forth about what's going on. Are you running into problems, whatever. And then we would say, okay, from this point forward, we're going to change the schedule out, and we're going to, change the objectives. And then we end up at this point, which is a little bit different than where we wanted to be, but it's still doable. Now, you couldn't do that unless you had a schedule on hand, first of all. So that's why we have this schedule. But also, it makes sense, because if I want to, change course, I can't just, I have to know where I've been. I have to know what kind of goal we're out for. And then, if we change course, maybe we can pick another option that's, within the scope of that. So it really helps keep the project constrained. It keeps people from kind of losing focus and so forth. So, we don't necessarily want perfection here. So, like the rest of the proposal, it's not about perfection. It's about, just making something that we can work with, that gives an idea of what that you can work within your resources, that you can work on a schedule, but also that you can be adaptable to that schedule. So in project management, oftentimes you have to rescope something. You have to keep things sort of, relevant to the week that you're in or the month that you're in. Sometimes over the course of a year, you might work on a project, and that project might, it might change over that year, and your goals change. And so you have to be adaptable to that. But you have to also do it within the framework of the project. A lot of projects fail because people don't plan, not that they don't plan well enough, not that their plans are perfect, but that they can't make those adjustments within the scope of the project. So that's what we want. That's the kind of a project sort of proposal we want. Those are the kinds of things we want to learn about, and so forth. So I had a comment in the chat. Okay, so Adama said, if we are selected, how will we share our codes via GitHub? Yeah, so we would work from GitHub. And if you're doing, so I guess that's the third path to success, is knowing something about open source principles. And kind of that's what you would learn during the project period. But yeah, we usually work from GitHub. So we work with, making the code open. We, ideally like to have everything kind of pushed to GitHub. Both, if you mock up something for the coding period, and during the weeks that you're working on it, having a repository that you push things to so that we can review them in meetings. With VR and XR, it's a little harder to do that, because your code is Blender code, or it's maybe Unreal Engine or something, and it's not easy to see to share the code as you might with like a project, or if you're building a machine learning model. So that's something we'll have to work on. We'll be basically working out of GitHub. Like last year with Vrushali, what we did was we had, she did some things in GitHub. And there were some live demos that she did. So she would share a screen. We'd see some, fly-throughs of in Blender or something like that. And then at the end of the period, at the end of the project, she archived everything on Zenodo. So we had, a place where we could go back and look. And the reason we did Zenodo is because you can't upload really big files to GitHub. So it's not, it's not a thing that we can do. That's not a practical solution. But for smaller things, we can use GitHub, and we'll be using that. If you're not familiar with, sort of the style of GitHub, the type of, project management that GitHub offers, I would take some tutorials in GitHub just to get familiar with it. But otherwise, that's how we'll work. And we'll also have weekly meetings, which are, opportunities for people to give feedback on their work. We usually kind of do a Scrum style meeting where we say, what have you been up to this week? Do you have updates? Do you have things that you want to improve upon? Do you have things that didn't work? Do you have things that did work, and so forth? So it's definitely we're definitely hands-on during the coding period. So you have that opportunity to, rescope your project, or, give updates week to week and get all that feedback that you need to be successful. Okay. Any other questions on that? So let me share my screen again. Yeah, so the third path to success here is to have, the third path to success here is having this version control and archiving. And so again, it's like, a lot of people know how to do this, but like all organizations are different in how they prefer to do this. So, we usually have people, sometimes they fork repositories for the organization to get started. For these projects, we don't have a huge amount that's in a repository. We have things that are all over the place. So, but you do want to be, because you will be working out of a version control repository in GitHub during the coding period if selected. And, it's a good skill to learn. And then, of course, archiving your work. So we want to have everyone not work on their local computer. We want to have them archive it. And so we'll work on that as well. Okay, so any other questions or comments about that? Morgan, you've worked in open source, so do you have any comments?
Well, just following on the comments from last week, as you said, like there's so many different directions to go with that in terms of what does sustainability look like to you, or what are the important features of sustainability for you? I dropped something in. Open Science? I forget now which. I hate that we have to choose a channel.
Yeah.
Sometimes. Yeah. So I'll look it up in a minute. But the Turing Way is a community project from the Turing Institute, Alan Turing Institute in the UK. Right. So this is a multi-site. It's one institution, but it draws on multiple institutions in the UK for data science and does applications. And anyway, the project itself is a kind of a community book, and supposed to be kind of best practices. And she wrote a 2-year anniversary piece about her experiences in managing her, as well as to some degree these questions of what am I supposed to be doing here?
Yeah.
Is like asking herself, right? Like what is what am I trying to accomplish? What am I trying to promote? What am I trying to and probably have sunk long time ago, has sunk down the Slack memory hole, which is so unfortunate. But there is a Software Sustainability Institute, right? So and there's another group too. I saw this in the UK first, and part of that is because I did my grad school there. But the research software engineers of the UK academic institutions got together to have a conference for themselves, and talked a lot about these issues, in the sense that we would see a lot of software get developed and then never get used by anybody except the person who had the whatever grad project to build that, or a postdoc project to build that, and so there was this can we do more to build on each other's work, and in the true ethos of the open source community, where it's like you scratch your own itch, but hopefully that's something that probably somebody else is going to need to do too.
Yeah.
And by collecting that, by following good software engineering practices, and documenting it, that work can not only solve somebody else's problem, but potentially be the basis for expansion, or other solutions in other domains, right? So either people can learn from it, or they can actually repurpose it, and so those are the things off the top of my head. I would love to hear back from other people. I believe it's Ben Cotton was recently released from Red Hat service. We're trying to think of the right euphemism here.
Yeah.
But so longtime community manager at Fedora, but who held a paid Red Hat position, and I'd love to hear from them, and certainly trying to plan something. I see now that Flock to Fedora, which is their annual kind of developer conference, is at the same time as computational cognitive science, which is damn it. So I'm trying to figure out how best to do that. But they're would love to ask, again, like, I bet you if you asked 10 people in the open source community, you'd get 10 different answers in terms of what are the important things about sustainability.
Yeah.
Well, let's say 5 answers. There'd be some overlap there. But and just wanted to say on the personal interest on the XR front, I'd love us to have a meeting with like USC, UCSC's Genomic Institute, and be like, look, can we follow some of your organoid culture people around in terms of be a great use case for a lab where it's like you've got to interact with multiple complicated pieces of equipment and culture, with culture, right?
Yeah.
So it's not just that you're, yeah. So basics, yeah, and it's not just cell culture that you might get from grad class, but this is bioreactor, and so yeah.
So modeling that in XR, or?
Yeah. I mean, like again, it's very much a living lab, right? So literally.
Yeah.
Or that's its purpose, right? So something where you could. I mean, it just seems like such a great use case.
Yeah.
Totally biased. So take it with that caveat. At the same time, I'm always looking for a good in. It's either it's Stanford, which does this. I think the course is going to be starting soon. So they do the annual brain organogenesis excuse me, course, and I still haven't gotten the training materials from that. Love to see that. There's a group at Johns Hopkins that I'm going to try and get into in terms of just what are their practices.
Yeah.
They're coming at it from toxicology and non-animal testing, and which was interesting. Did I share the open water health document? The Google, like Google Drive. I mean, Google Doc.
I think so. We talked about open health, but you may or may not have.
That they were doing they're doing cerebral organoids culture for cancer research.
Yeah.
And okay. Anyway, so that was really interesting. But that's exactly what this Johns Hopkins group it focuses on, right? They're really using organoids for cancer research and other types of research where the standard practice would be get mice, give them cancer, have tumor grow, test on said tumor, right? And sacrifice animal. Right? So this is the idea with organoids is, hey, we can do that, quote essential part, which is really just growing the tumor.
Yeah. And
then testing the compounds or testing whatever it is that you're trying to do. We can do that on lab grown tissue as opposed to working with animals. Anyway, but at the same time, like these are complicated procedures, and somewhat expensive, So having a VR, having a virtual lab to really practice this, I think would be really a benefit, Again, totally biased.
That's fine. Yes, that's great. So I had some. Well, I'll pull up the Slack in a minute. Actually, I can do that now. Actually, so let me share my screen. There we go. So this was in open source or open science.
Are you looking for the
thing you were talking about? Yeah.
From the Turing Institute.
Yeah.
Oh shoot! What did I? This is my apologies.
Could be in the summer of COVID.
Maybe I put it in. Oh, you know what? I sent it to you guys directly.
Okay.
I'm sorry. I sent it to you too because I couldn't decide.
It's okay. It's okay.
So
Yeah, we'll do that.
I said it here. I'll post it. I'll post it there
Oh yeah.
in Open Science. Okay.
Okay. Yeah.
that reflected my problem there.
There we
you
go.
should-
Open Science.
you
So
should see it in Open Science.
yeah, there we go. All right. So this is this article, Ali Steele blog. So I'll open it up, and this is this is open source sustainability. This is more of sort of a narrative approach to this. And the Turing Way is a group in the UK where they do a lot of things with, like, working open and things like that. So, and the Turing Way is.
But it very much focuses on data science and the software for it.
Okay. Yeah. And so this is from the Alan Turing Institute. So there's sort of this open source arm of the Turing Institute.
Yep.
So yeah, this is where I think they worked as a scholar in studying open source communities. And when I first joined the Turing Way, I was a self-identified outsider to the community, tasked with the role of managing it. So this is the community manager role that people have, where they try to organize the open source community. And so this person was a community manager, but was also an outsider to the community. So they had to sort of get integrated into the community and kind of learn what the community was doing and how to facilitate that. So for the first 6 months on the job, I did what I know how to do. And this person is an ethnographer, so they employed ethnographic tools to learn more about the community and document learnings on a weekly basis. So there was a GitHub issue that was based on this. So this was the GitHub issue here, which was number 2318, Community Research Learning about the Turing Way. So this is like kind of where you would create an issue that is not really code-based, but it's like kind of how to sort of sculpt something. So, people create issues, usually they're pretty technical. This is actually more of sort of a learning and design issue. So they created this issue, kind of a summary. What is community research? So there's this community research aspect where you're trying to learn about what the community does. And, this is community-based participatory research, community network research, research ops or ethnography. This is the research plan here, where you have basically this process, the tools you use to execute the process, and then questions that arise from those processes. So, for example, if you have conversations with community members, use a host of tools like Zoom, Jitsi, Microsoft Teams, and Calendly. So, you have tools for video calls, tools for note-taking, tools for scheduling, and so forth. Also things, like data processing. You can use Miro for, qualitative analysis, GitHub, Slack for conversations, and then open source alternatives to Miro. So Miro is a closed source platform, so we want to find open source alternatives, and then public release. So, thinking out all these sort of stages of kind of the community and what the community's doing, the tools you need, and then the questions that you have as you learn how to interact with the community. So I think that's an interesting approach to sustainability. You have, you come in as an outsider, you kind of live in the community, you're charged kind of with, how do you get the community, shaped and involved. And, it's like you have these, you kind of probe the community and you have these questions that then, you can try to answer. And in doing so, you can make things more sustainable. Why open science is a good question, because it's like, why do we even want to do things open? Why do we want to work open as opposed to working closed? Which means, people are working in sort of a public sphere where they're sharing information. There's, permissive licensing of things, as opposed to locking things down, being proprietary. And then, some of the things that we're interested in, are there trends in where, why, and how people contribute? How can I share my findings in a timely manner without overwhelming people? Are there personas for contributing to an open source project? And can you celebrate people's accomplishments in the community? Does it have an effect on sustainability and so forth? So I think these are great. This is a great sort of breakdown of these things. So yeah, that's this Miro board, and then this is the issue, and then this is the article here where they kind of talk about sort of this experience. And so I'm an anthropologist, sociologist by training, which has undoubtedly influenced both how I write and move through the world more broadly. More explicitly, I lean on Ruth Behar's idea of the vulnerable observer, the notion of studying up by Laura Nader, Clifford Geertz's thick description, Anna Singh's notion of friction between constituent of global systems and their design, and the Zapatista's idea of a pluriverse. So these are pretty technical terms, but she gives links here. There are more, for example, that these have studied infrastructures, care, emergence in the commons. So yeah, she's coming from a certain position and kind of working through using some of these theoretical ideas to look at sustainability. So there's some reflection here on some of these points. One is 10 practices I've learned from 2 years. The development of digital third spaces like the Turing Way. So you have digital spaces that are sort of proprietary or controlled by sort of a corporation. You have other spaces that are sort of disorganized, people using things sort of individually. And then the Turing Way is sort of this open source space for doing things. There's also this theory and praxis of community building. There's, of course, this question of governance. How do you develop governance? How do you sort of understand openness in different types of spaces? And, it depends on the space. Our approach to open source, our approach to open access is going to be very different from if you went to work for Linux, or if you went to work for some other tool-based organization for Google Summer of Code. It's a difference in culture, and that's fine. It's just it's dependent on the community. It's dependent on the organization and what they're trying to do. And then working in science versus working in technology, and the differences there. So our group actually blends science and technology and even some other things into it. And so we have a kind of a unique blend of work styles and working questions and things like that. And so, that's always an issue. You want to know in your organization what they kind of value or what they kind of focus on, and it's going to affect how they approach openness. Okay.
I think it's nice that you also talked about burnout, and talking about her own burnout.
Yeah.
But it's something that you definitely becomes another issue with open source projects. Not everybody's lucky enough to actually have the project be their work project.
Yeah.
Sometimes dealing with the social issues of issue management it can be vexing. And again, I'm using polite euphemisms.
Right.
Depending on how popular your project gets,
Yeah.
And again, it's always good to see the NumFocus family grow larger with a new round of projects that were brought in.
Oh yeah.
But again, it's so common where these projects are led by one person, or a very small group, and every so often you'll see on Hacker News somebody talking about giving up their project because they just they just can't personally handle the project. It's not so much of a technical issue as it is it's a burnout issue.
Yeah, that's all very good food for thought. I did want to get into the discussion here in the chat because it was there's a lot
Vrushali
here.
would like to do a presentation.
Yeah. So let's see. Dama said, are there other persons who are interested in VR subjects? Is it possible to make some collab with other students if this is the case? Yeah, I don't know who the other people who are applying to the project. I know that Vrushali is here. Hello, Vrushali. And Vrushali, of course, worked on this last year. And she's interested in VR, kind of continuing in VR. So I don't we could create a collab notebook for VR stuff. If you're interested, we can of course share it amongst ourselves. This is where, we might create like a set of demos it's kind of hard to do, but like with collab, you're just kind of preserving code if you're working on like something like a physics engine or some, whatever the code is, you can put it in there and we can share it. And then of course that's something you can put onto GitHub and get feedback on as well. So we can all fork that place in GitHub where that's going to be posted. So definitely, I think, either having like a notebook or having like finding out who's interested in the project. And of course, whether or not you get selected for GSoC this year, we still invite you to attend our meetings this summer. We're going to do an open source meeting. So that's also a place where people will come together. You can't really collaborate on the proposal itself. Like if you're making an application, you can't just, have like multiple people working on it. It has to be individual people working on, their own kind of idea. But, when we start the coding period and we start the community period, we will be kind of working in a group. So we'll have an open source group over the summer, and we'll be attending this weekly meeting, and we'll all be kind of sharing ideas. So there will be a collaboration in that sense as well. Okay, then Jess says, but to the point I've actually considered there just being one big news channel, really. This is for our Slack, and maybe some kind of tagging for updates. Yeah, it's just basically the vagaries of Slack where, you have to pick a channel, and there are a lot of things we sometimes cross-post, and it's,
Well, the Slack thing is just the classic issue of news updates versus project updates, and I think it's just it's sort of like it's fine, but also like for people coming in the lab, I think it's very like confusing when it's just I go to this channel, it's just a bunch of updates that don't have any context. So it's sort of like what do we do that with that administratively, and that's sort of a discussion to have elsewhere. But it was I think there's a place to have more specific updates, and maybe that's just the Discords, the bits and bytes server, which is particularly relevant to VR stuff, or the other server. But that's sort of a as people come in and look for things in the lab going on, feel free to ask us about what does it mean, what is going on in this channel. You could or there's a channel about this. What does it mean? Just feel free to ask us so we can explain some of the content or like what has been going on in that space if it's not clear. I think that's sort of an important thing for people coming in the lab to hear or understand. So that's all.
Yeah, I think that would be useful. And then people come in at different times, so it's like if we had like that kind of feed structure, where do they start in the feed? They usually start with the most recent thing, and then there's stuff up in the feed. Like every year we have this with GSoC because people come in and want to learn about the the resources, and you can pin things in a Slack channel, but it's like, okay, well, you tend to repeat yourself in terms of where the stuff is. And so, we could use like Medium for that. We could use, like some sort of blogging platform, but it's the best practice is elusive here. Yeah. Okay, so then Jesse's answering Adama. The short answer is yes. I'm not sure if you're familiar with our summer cohort option, which is what I mentioned, that if you're not selected for the project, you can still participate. And we usually like to, help people craft projects because you do some legwork for the proposal. So, working out a project, if that's something people want to do, is always useful. And in its relation to the GSoC projects itself, it's not unusual for a group of people to form around the GSoC projects and continue them through summer or fall. Yeah, that's our open source meetings in the summer, which we have we did last year, and those are actually, if you go to our YouTube channel, we have an open source channel where we have those meetings archived, where we had a lot of discussions last year on different topics in project management and open source, and we'll probably have new discussions this year, and really kind of it helps people learn a lot about open source, kind of develop their projects, develop their interests. So that's always good. And then and then Jesse has a few stories about demo or die mentoring. Okay, and then yes, Vrushali, welcome. Yes. Oh, you want to give a presentation on a project, Vrushali? Yeah, Dama said she'd like to see that. But we can certainly do that today if you'd like. Or is this for another week? Okay. Well, yeah, if you want to do it, let me know here. We could do it this week or next week or whatever. But I let's see. So I think I don't know if Jesse wants to talk about what he was going to talk about first, and then we can go. I have some things also to present. So
Yeah, I can speak very briefly. More like a teaser to follow up on later if Rochelle wants to prepare, get ready present her topic. Yeah, and Adama, yeah, that's kind of what I thought. I didn't think you meant like collab notebook necessarily, but I think there's space to have collaboration both through the cohort, but also there is a VR channel in the Slack. You might want to search for. I think it's called just VR Neurotech or something. It's the latest one that we have. And there's also the Discord. Maybe Bradley can speak about the bits and brains and bytes and matter Discord, which I always say the wrong way.
Yeah.
But there's interest there. Vrushali did a lot of some VR work last year, and also Hussein, who is not here today, recently attended a few virtual reality-based hackathons. One was at NeuroReality in Colombia, and he's very much in that space, and he's kind of done some like direct work and other work, like interest in that space too. So there's a few people here who are definitely interested in that broadly, and then there are opportunities, and that's something that I think is a really great point of the lab, not just for Google Summer of Code, but in general, is that you can say, hey, I'm interested in working on blank. I'd like to make a project around XYZ, or either lead one or join a project or lead, follow up something. And if you mention that to us, I'm the lab manager, research coordinator, and Bradley is the director. So any mention it to either of us, or just say it in general if you're interested in whatever, or try to even specifically talk to Bradley and say, hey, longer term, I'd like to do X, Y, Z. Like Bradley will be, he can help try to craft that. So if you are, that's maybe a longer term thing, but that's something we really encourage people doing because it's a great space to develop projects and bring people together under certain banners if you want to do that. So that's a little bit of a soapbox about, the virtues of developing projects. But yes, there's some interest here in the lab, and continue. Encourage you to ask about that, reach out about it, talk about it, mention it, and see where things go. And yes, apply to Google Summer Code. Anything else you want to add to that, Bradley? I can say stories too for a little bit. But...
No, I think that's fine for now.
Okay. Excuse me.
The Discord link that Jesse was referring to is off of our main website. So if you go to our main website, let me put it in the chat here. It's this website here. And if you go to that website, you'll see that there's a tab called Education. And you go down to the Education tab to the topical Discord servers. And it's called Principles of Bits to Matter to Mind. And what we've done there is there are a lot of like topics and like different news stories and papers and things that we've kind of collected. So it's a nice treasure trove of things in VR and XR and different topical areas, technical issues, different types of readings that you really can get you really interested in some of the things that are going on in that space. And it's sometimes not easy to follow what's going on in that space. So it's good to have a resource like that.
I'll just be really quick. And I don't know if Vrushali is still there or not and wants to present, but I'll just sort of fill in the gap. First, and this is sort of a little dovetail to one of the cool things about the summer cohort that we've been doing kind of since last year is we'll talk about open source life. We'll talk about Google Summer Code specifically, but also we have nice like professional development, early career kind of sessions, or like parts of the discussion, parts of the weekly meetings might center on like, oh, this happens, or this is something to think about, or this is how you communicate in the situation. And one of the things we talked about there is sort of demo or die or deploy or die, which is broadly a concept of having something you can show somebody on like it prepared in advance, because when the opportunity arrives, and someone like important walks in, or there's a fun like someone's like, okay, well, we got to figure out a funny thing. What are you doing? What are you doing here? And then it's like, are you ready or not? And that, especially when you're developing things or ideas or projects, in quote unquote the real world, or when you're trying to get funding and stuff like that, there's a definite sense of having that in order. And what does that mean? And that's sort of like a pragmatic view of it. We've talked also sort of from a teaching point of like, how do we encourage people to have like get used to sort of presenting ideas in a positive environment where criticism is constructive, and how do you prepare someone to be in an environment or to be in a moment where, okay, it's a demo or die kind of time. So that's a little bit of like broader background. But my specific story for this week is there will be times in your workplace or whatever collaboration, but like often at work or like in industry or whatever, where there will be a meeting going on that you know about or may not know about. And then one of your colleagues or a manager will say, hey, Jesse, can you join this meeting? Out of nowhere. And you'll over time realize that sometimes people get called into meetings when there's a lot of consternation or a lot of like not knowing what's going on, and people are kind of reaching for solutions. And you may be brought into that situation unawares, or like just kind of almost as like well, we have somebody working on this, so that's covered, right? Kind of a thing. And how that applies to what I'm talking about is I don't encourage, trying to be super paranoid and think about every possible outcome that could happen all the time. But I do think I had a very interesting situation this week where um, sometimes you can see problems in projects or in workplaces emerging before they fully come to a front, let's say. And how demo or die applies to that is, there will be opportunities where if you have some work sketched out as a possible solution to them, it can be interesting or useful, or like just it's sort of in a somewhat Machiavellian sense, is that there's sort of the no crisis should be wasted in terms of presenting an idea or showing up. But I'm much less trying to encourage sort of, I don't want to encourage the hypervigilance about that or being uneasy about that. But I guess I'm just sharing the experience of understanding that it's, if you have an idea about something and you want to be able to use it to justify funding or an allocation of resources, or even just to show the effort that you have done in something, it's very wise to consider that in the moment that it will matter, like in the moment that it comes up where someone's looking for, is it like, I'll use myself as an example here, but like, oh, Jesse, like, hey, you're doing a lot on this space, but like, what's the current state of it? And talking about things is one thing, but being able to show, okay, here is something that is happening, matters a lot. And again, like this is almost like, I'm saying this and it's almost somewhat like very, very contradictory to Google Summer of Code, which is a very long, slow, drawn out iterative process. And I'm not saying this to imply that that situation, or particularly in the lab, we're heavy on like, oh, random quiz, you better be able to show us everything you're doing. No, not at all. Not at all. This is very, very much a specific commentary on, I would say, certain workplace environments. But there's a dovetail into something I'm looking at a lot lately called expert writing, which is about people in a very specific niche space of study having to communicate their ideas and importance to people who are maybe in a more general space. And it applies here too, in the sense of just when you're in environments that we have to communicate or justify the value of something, which is different than most like academic programs, because the incentive is that you're paying them to give you feedback. When you're outside of those environments, things can be different and strategies can be different for how to justify the value or like why things are happening. So I know that's a little bit vague, but I realize I don't want to spend too much more time to take away from Vrushali's talk, but I don't know. Does anybody like Morgan or Bradley or anybody else want to comment on that or add to it or contradict it or whatever? You can discuss it for a second if you want. But my the only other thing I'll say is I think those kind of discussions are really important, because a lot of times you don't really get a space to talk about, okay, hey, I had this happen, or hey, what's going on. And I think one of the nice things about the community here is like we don't always talk about it, in front and center. We don't talk about it, we could talk about it in more private situations or more in specific situations and whatnot. But there's a really nice mentoring component to like, in your career, this happens and what do we do about it? I think that's a really important thing to have like a space for. And then the last thing I'll say is I had a nice experience this week where someone, a sort of a colleague of mine, got accepted to a university graduate program around kind of in the Boston and Cambridge area. And we talked a little bit about that, and talked a little bit about the process of selecting the school and why the school is different, and sort of the justification for going to graduate school, and how it can be, fit in line with a lot of plans, or fit in line with, identifying you want to pursue that path as a researcher, or developing a specific like project or what you want to do in your life. So I'll just say it was a good talk on a mentoring level, and also on a hearing about those programs, and for people who are considering grad school, or if you need a letter of recommendation and you stay with us for a while, we're pretty good about trying to help and support with that too, for other things you want to do. And it'd be great. I realize this, but it'd be great to track a lot of our alumni have done things. Like I know Stefan did a lot with bioinformatics, I think, and Rish did things with art and neuroscience. And I think Ankit is working in a different location now too. So we have sort of this interesting alumni network of all those things, and it's a nice. I like being able to talk about that. And Bradley and Morgan have a lot of really interesting experience in neurotech and biology spaces, and a lot of experience. So just saying, keep that in mind as resources for you down the road. But that said, I'm looking forward to Vrushali's presentation. So whenever you're ready,
yeah. As Vrushali, you can go ahead. I just wanted to mention that our meetings are going to be kind of we try not to do what Jesse said, which is have a meeting in search of a solution. That's why we kind of have these more structured meetings, and so it's kind of you can come to maybe a solution, local solution, by talking it out, but you don't want to just kind of go into a meeting and say, well, we're just gonna kind of figure things out, and then it's not really that not a good idea to do something like that. So that there's a balance there, and so that's something we'll talk about in professional development and that. So Vrushali, thank you for volunteering to talk. So go ahead.
Yeah, thank you. Let me share my screen first. Is it visible?
Yeah, your screen is visible. Yeah, I see your slides coming up. You have to click on, right there.
Yeah. So this time, last time, I contributed to VRDR, which is the virtual reality for distributed research project of GSoC. And this year also I wanna kind of contribute because I like VR. So this is it. So I thought of contributing this as this year. So last time I tried to make kind of a lab scenario where this first scene will be a showroom where we can showcase our different kind of sub labs which I have introduced last year, which are first is anatomy lab, second is the model organism, where C. elegans is also there, which was our first preferences at the organism list. And third one is the Morris water maze experiment. So here all the pictures or the pathway to that will be portrayed. And the most important thing is whoever the participant is, we must collect their data information and their which project they are clicking to, or the lab or the scene they are in. So these are the UI I made last year. So I will continue doing this and make some kind of improvements in this thing. So first lab is human anatomy. These are the models I made. First is an angiology and different kind of skeletal and different. Here is one robot also, which will give a hints where to step and give the information about the things. Like here first is the welcome note for whoever like getting inside and the tutorial for that thing. And next is virtual reality lab second, which is the Morris-Water maze experiment. Morris-Water maze experiment is the neuroscience experiment which is used to trace, I guess, memory and whatever, like memory and path. So here I kind of wanted to mimic that in reality. So I will use Unity 3D ABMU, which is the agent-based modeling in Unity. Here we will use NavMesh. NavMesh is the pathfinder, like, just 1 minute. Yeah, NavMesh is the agent pathfinding way where there is one place, like we have to put that mice at that certain, like it will retrace all the path you will went and track all the points, and it will be first person view. So the person who is like in that project will have to perform that kind of a game, and we will track their time and their path for recalling or like collection of data we will have. And next, like this is the construct data and the motion tracking. This is the mice. We will perform as a mice there, but we are the first person, and this is how it looks right now. Last time I just made kind of models and make it, and now I want to make it like a real world thing. So, and third one is the modern organism thing, where there are C. elegans and the rest of the organism which are used in kind of biology to learn evolution and to basic things. So here are these model, like animal cell, plant cell, plant and yeast, fruit, like fruit fly, C. elegans, flatworm and vest, like frog, mouse, zebrafish, sea urchin and fish. These will also have a little bit highlight after C. elegans because it was our main focus at that time. So milestone I kind of tried to complete in 2023 was develop 3D content and created optimization of those models. And now I want to make these in VR belts and make it visualization navigation for Morris-Water maze, and rest the visualization and the naming plotting for learning purposes. So I intend to make VR NavMesh for Morris-Water maze, VR anatomy for visualization and like naming little things and understanding those things. And third one is organisms. This anatomy and the organism kind will be a little similar, and like the VR NavMesh will be a little different. So it is important to us because we are kind of a researcher and scientist, so we want to promote efficiency, collaboration, and learning most prominently. So I wanted to make it good project. That's what I urge. And thank you for listening my talk. That's it for now, and I will try to make it good.
Well, that's great. Thank you. Do we have any questions or comments? Okay, yeah.
Yeah, no, that's great. I was just trying to think of more assets in terms of the human body, and it's. I'm trying to think of the project, but these biomechanical simulations that Gitware does. I'll search and I'll drop it in the VR channel.
Yeah.
Super interesting. The other thing is I don't know if neurorobotics.net still works, but they did the water maze and some other. Here, let me just see if that still works. Again, some of these, traditional psych experiments, but it'd be worth seeing what they did. Oh, yeah. I'll drop the links in too.
Okay.
Really nice to see. Yeah.
Thank
you. Yeah.
So yeah, it's good. So you could so those are basically the three categories of things that you have in your platform.
Yeah.
And then you could drop new content in. So say I wanted to make another type of experiment,
Okay.
yeah.
So after, what I'm thinking is after completion of these steps, these goals, we can add different experiments here.
Yeah.
Neuroscientific experiment for participation of any people, and make it a more research oriented instead of just this VR project.
Yeah.
We have neuroscientific project, Morris water maze, and we can add other as well.
Yeah.
There are such things.
So I mean, I'm just thinking in terms of if other people wanted to contribute new models, if they had a model they wanted to put into this framework, and then the idea would be if we wanted to create an application where you could go into this environment and pick what you wanted to look at. It could be an anatomy model or an experiment, and then it would just be okay, we have this collection here, and then you could just pick which one you wanted to use. And I'm just thinking about the long-term sort of how you would build onto this. Yeah.
Yeah, we can think about this later after completion of things.
Yeah.
And does Unity give you agents? Can you add agents?
Yeah. There are some frameworks in Unity. We can use ML agents there are, and reinforcement learning. We can also add that one. And plus, here is Navmesh I use because Morris water maze experiment is a pathfinding thing. Kind of a mouse has to find its way to a specific location. So that's why I use that. But rest we can apply an ML agent as well to make it more it will be way complicated. But yeah, we can do that thing as well. Frameworks are there, specific things.
Yeah. I mean that's what I was just wondering. If you've tried that, where now put an agent in and let it solve a
yeah, we can do that one as well. But first, what I thought, first person view was important, and then we can add that mice to do that work. But it will take a lot of training. We need that thing, and it will take time for that mice to go there and that specific location. So it's kind of
for sure. Yeah. So neurorobotics .net was the old link for the Human Brain Project, European Human Brain Project, and they had a virtual rat that they would put into. They were using Gazebo as their simulation world, So this is the simulator from the ROS, Robot Operating System, kind of developers. But same ideas in that, like, make a world and then put agents in and train them in that world.
Yeah.
You can computationally make the mazes
we can
harder.
do that here as well.
Yeah. Okay. No, that's great. And and that also just reminds me of NeuroNav, which is this IDA Mamenidad? No. Yes, Mamenidad.
There you go.
And I just dropped those links in here.
Yeah.
Yes, please.
Yeah.
All right, that's great. Well, thank you for that presentation, Vrushali. Very good. Follow up on that. I don't know if we had any comments, any other comments before we move on.
Oh.
Okay. All right. Well, yeah, that's good. And then we'll continue to think about that. And definitely, we want to do a collaboration here probably over the summer. I think there are probably people interested in doing this. We'll get to that point when we get there. So, okay. So I wanted to make kind of a couple of announcements about what happened the last week in terms of presentations and conferences. So I did a presentation on Monday for this festival that they have. It's the Society for Mathematical Biology. And I did a presentation on behalf of the OpenWorm project, or the DevaWorm project, DevaWorm group. And it was called The Mathematics of DevaWorm. And this is a festival that was organized online. And it was, basically a bunch of topics in mathematical biology, which was quite nice to see. A lot of people interested in modeling different problems, different systems. And I did a presentation on sort of the different mathematical models and techniques that we've used in the DevaWorm group. And so the DevaWorm group is coming up on its 10th anniversary, actually. So that's coming up next month. And I'm going to release a video on the DevaWorm YouTube channel on this 10th anniversary. So just kind of going over what's happened in the last 10 years, which is a lot of stuff. And it kind of revisits a lot of things that have been, have been in the past. And that's something I think all projects should do, is kind of get that sort of archaeology of your project every once in a while to remind people where we've been and what kinds of research threads that exist in the group. So that's coming out. This Mathematics of DevaWorm talk is also on that YouTube channel. It's a different YouTube channel than the Orthogonal Lab. I just search for DevaWorm and you can find it. But anyways, it was a fairly well-received talk. Basically, it goes through the different types of mathematical models we use in DevaWorm. Things like cellular automata, deep learning models, connectomes, network theory, or network science, other types of models that we use, representations, such as we have this n-dimensional representation of the embryo that we can then apply to different problems, things like that. So it goes over a number of those models in detail. And so it's like a 15-minute talk. So it's not really deep detail, but enough so that you can get a sense of what we're interested in terms of mathematical modeling. And then this 10th anniversary talk is going to be like on some of the, some of the stuff that we've done with cellular automata over the years, some of the stuff with lineage trees over the years, some of the stuff with, we've of course had a Google Summer of Code presence in the DevaWorm group for like 5 or 6 years. So we've, we have a lot of alumni from that. We have a lot of projects that have been driven forward from that. So that will go over a lot of that. So it's very, much an open source participatory group that's been around a long time. So nice to see that. Nice to get a chance to revisit it. Then later in the week, we had another conference, which was the Embodied Intelligence Conference. So I gave a presentation on behalf of the group on some of the stuff on Bradenburg vehicles, developmental Bradenburg vehicles. And so that video is online. So I'll go over actually the Embodied Intelligence Conference now. So the first thing, this is the Embodied Intelligence Conference website. I got up the page on conference recordings. So they recorded all the main sessions. This was over 3 days, and it was based in London. So, the timing was Europe-centric. So, North America, I, for example, got to attend maybe the tail end of these, and then the what they called the breakout sessions. So, but the recordings are all here. They're on their YouTube channel. They have links through to this. And there were a lot of really interesting talks, a lot of stuff on soft robotics. There was an interesting talk on the evolution of organisms coming onto land. And so Neil Shubin gave that talk. It was really interesting. And there was this interesting conversation that resulted from that on the sensory abilities of organisms in different environments and the evolution of those sensory systems and the evolution of embodiment as a consequence of having, different parts of the body being repurposed in evolution, different sensory systems, and the representations that are built from that, and so forth. So it was really an interesting talk about that. And so this was, again, one of these interdisciplinary conferences where you had, roboticists, computer scientists, people interested in evolution, people interested in different other topics like philosophy and psychology. And so a lot of the breakout rooms reflected those diverse interests quite well. So it was a good sort of mix of people. There were some really interesting conversations in the discussion sections. And so I gave a presentation in one of the breakout rooms on self-organized systems or self-organizing systems. And it's this talk on the YouTube channel. So this is the Orthogonal Research and Education Laboratory YouTube channel. And this is the video here. Developmental Neurosimulation as a route to embodied morphogenetic inspired systems. They cut out intelligence. I gave the talk, but I can't remember the whole title. Isn't that just like what it is? So this is a 15-minute talk. You can watch it here. Basically, it goes over some of the latest developments in this project. Basically, it's developing Bradenburg vehicles from what you might think of as a virtual egg. So it's like this single cell or single body, which becomes like this 3-layered body, which then transforms into this vehicle. And then you're also, in addition to that, developing a nervous system. And so there's this body, there's this nervous system, and the body can be shaped by developmental processes. And that depends on what kinds of things there's a computational schema that we use to develop different body styles and shapes. And then there's this connectome that sits inside of the organism that links the sensors and effectors, the sensors being the things that take in sensory information. The effectors are the things that move the organism through the environment. And those connectomes then are shaped by a number of other computational mechanisms. So if you go through the talk, you'll see kind of the details of it and the logic of it. I'm going to try to work out some of this in more detail because it was a 15-minute talk. It was very sort of rushed, but to kind of work out the details more specifically in another video. I'm going to try to do that soon. But this builds on our work on Bradenburg vehicles and developing things like that through developmental processes. So we'll talk about that a little bit later. How people are using development as a way to model systems that are self-assembling, learning, self-repairing, and that sort of thing. We've talked about that in the group quite a bit. And I think there's a lot of interest because this video, I posted it on Tuesday, I think, and it's got 86 views. So, some of that was from the conference, maybe some of that was just people coming to the channel, but people are, it's kind of an interesting thing for people. And yeah, the software part of that is not worked out as well as it could be, but the conceptual part is getting there. So it's
Can you say more about the software issues?
well, we've worked on some software for developmental Bradenburg vehicles, largely for like the connectome, which it's hard to really kind of put together software for the connectome. We did actually cover a paper in the DevoWorm group this week on some toolboxes that exist, open source toolboxes to build expanding neural networks. We've also done some work on, working on a connectome that does things like multisensory learning, other types of expanding sized connectomes, and interacting with the environment.
When you say developmental Bradenburg, because when I think of Bradenburg, I think of almost a thought experiment. Right?
Yeah.
When you're talking about these connectome, the projects that you talked about at DevoWorm,
yeah,
were those experimental connectome toolboxes, or was it like the paper that Sarrah had sent out? It was like a life paper.
The A-Life paper, yeah. So
that was more like almost it was developmental neural networks.
Yeah. Well, yeah, a lot of this is more in the direction of developmental neural networks, although one of the things about this approach is you can use like small connectomes, which would be like for model organisms, like, there are some examples from aquatic invertebrates that have very small connectomes. Also, worms there are other types of worms that have very small connectomes, like less than 100 neurons. And then there's C. elegans with like 302 neurons. So you can like take inspiration from those connectomes as well and look at how they develop. And so, yeah, the idea is to like kind of put together a connectome from what Bradenburg vehicles are, basically just mappings between sensors and effectors. What we're trying to do here is develop small connectomes that have like some structure that map from the sensors to effectors, but not directly the way that like Bradenburg proposed. It's like this, maybe there's some indirect pathways, or maybe there are feedbacks. And so these are things that we can kind of model and get a handle on through this kind of set of techniques. But then also bring the body to bear. So how does the body influence how these connectomes look? So if you change the body, or if you change the shape of the body, or the locations of the sensors, the locations of the effectors, how does that affect the sort of the process of putting these connectomes together? And maybe you have parts that are innate, which means that they just get put somewhere at a certain point in time in development, and then that's where they get put in every organism. And then maybe there's another part of it where you replace parts of you'll have to watch the video, but replace parts of the connectome with more mature parts, which may adapt in relation to interacting with the environment. So there are a lot of options for modeling things in that framework. But when I say the software isn't developed, it's like we have some software for some things, and then we obviously need a lot more software development on that front. So that to do a lot of the other things that are going on.
Yeah. I mean, I'm only asking. Just I'm trying to get a better sense in my mind, like who's doing something along those lines, even if they're not necessarily thinking about development. Like not necessarily this particular question, but it's nice digging into the old videos of neurobotics, Human Brain Project. I mean, they were definitely trying to think about putting realistic connectomes in virtual creatures.
Yeah.
And I mean, it was neuro, biomimetic robotics. Biomimetic agents for virtual robotics. But the development part is the bit that doesn't get enough attention. I mean, people are usually like comparing particular connectomes, if you will, and in the current parlance, it would be comparing different neural architectures,
right,
in a cross-sectional way, as opposed to any kind of how do these complex architectures develop, and of course that's leaving out these what we saw from like the neuroanatomy course, the New York, who's the anyway that obviously biology has to be seen in the light of evolution, and
right.
So these are connectomes that were potentially developed for one particular environment and then had to get readapted for new environments, or so you've got a lot of history in those connectomes. And yeah, I don't know who's doing anything like that.
Yeah.
I keep saying I need to go through Josh Bongard's. Well, he's got a new paper. I dropped into bioevolution, I think.
Okay.
He's got a new evolutionary robotics paper, certainly someone. Oh, sorry, that's the. Sorry, that's David Hahn. I did want to talk about model merging because, but that's check before that link. Or sorry, maybe it's in Bratenberg again.
Oh yeah, probably in Bratenberg.
I hate
this one here. Oh
yeah,
yes, it is.
Yeah.
So this is a complexity digest link, but yeah.
Yeah. It's Josh, ACM, right?
Yeah.
I don't like if we looked at his evolutionary robotics course, I think it would have nothing about connectomes,
right?
I mean, just looking at that, it's still these reinforcement learning policies, which is
there's something interesting there between like reinforcement learning and evolutionary programming and development, but I'm not sure what that is. I mean, because they speak different languages, but they're kind of headed in the same direction in some ways.
Yeah. I mean, yeah.
So so this was the Bongard paper. This is sort of an evolutionary robotics overview, maybe. And then this other paper by David Ha. Do you want to say some words about that?
Well, I haven't. So I wanted to compare it to another. Some Hugging Face people were talking about model merging, right?
Yeah.
So I assume this is again trying to. It's a foundation models plus kind of. Which is where we are now, right?
Right.
It's like we've got a number of companies that have the resources and the legal departments to handle all the data concerns.
Right.
So they've got all this data. They've trained these massive models. And what people are trying to do now is how to make them better, so fine tune them. There's all these euphemisms for it, right? But
Right.
it's basically the first model is great. It's quite general in its intelligence, but it's absolutely not superhuman, and that seems to be where we are in terms of I've been. It was a great talk. I don't know if they've posted a video of it yet, but Phil did had I think it's Brad Love did the Brain GPT. So
Okay.
this was using LoRa, which is a technique of fine tuning, which is a computationally tractable for a small academic research lab.
Yeah.
Fine tuning. I should add that. To produce a model where he is trying to create a research assistant.
Okay. Yeah.
So let's fine tune this model to be able to give me guidance on the literature of my field. I have a hypothesis which paper, which published results suggest or would be the most likely to give me scenarios in which to test that hypothesis.
Yeah.
In terms of it, like, oh, they've already collected the kind of data that you need to help confirm your hypothesis, right? Not necessarily doing the science for you, but kind of very smart lit searches to some degree, right? And definitely, as you put it, science augmenting.
Yeah.
So I haven't. I only got sent this just recently, in that somebody I know is going to be in Tokyo and wanted to try and meet with David. And this I saw only got like you can see from the date, like this is this week. And I think we talked about Sakana AI. So this is his new company.
Okay. Yeah. Yeah.
And this like off of their company webpage, like this is their focus.
Okay. Yeah.
And sort of the evolutionary doesn't surprise me, being that again, his job postings have A Life and Gecko.
Right.
Contributors welcome at his job postings, but that Hugging, like some Hugging Face researchers. Oh yeah, you know what it was? It was Light On, which is this French photonic computing company, had a talk this week with, it was Hugging Face people, but it was on Light On's channel.
Okay.
Sorry, that's confusing. But talking about model, like this additional, you don't have to just be an evolutionary approach. So other people are doing this, and it does seem to be like every almost like 50% of the machine learning papers I'm seeing are some sort of fine tuning of a current language model. You know, so it's like chain of thought, it's RAG, it's LoRa, it's it's like all of these things where you can there's really this great initial interest and performance, but once people start actually trying to use them to create products to do anything, they're hitting particular problems, and I gotta say, I think I posted this too, probably in Dev AI or something, but like I'm kind of with Gary Marcus, like this is not gonna get us there.
Yeah.
He had something on
Yes, this one.
Yeah, there's probably that. It's
Right.
the no AGI. Yeah. But this also comes from just his Twitter feed in terms of he's like willing to make bets with people like 2025. We're still not going to have AGI.
Yeah.
We're going to have marginally improved performance. We're going to have more, because there's so much money flowing into AI, we'll have more companies making these big models. But again, their particular performance will be. So I'd love to dig into. I'm sure what David Haas is working on is interesting.
Yeah.
But, I haven't. I'll try and follow up with a thread on there.
Okay. So one of the topics too, and this happened sort of independently of these meetings, but also in the festival that was the first meeting of the week. There was a lot of talk about almost like climate models for biological modeling. So when they say climate model, I guess they mean like a large unified model, but something that runs ensembles where you have different types of sort of models have different types of assumptions, and they run, and you kind of can average them together, or you can get like different, model with different scenarios. And so there's this, people are interested, especially with cell modeling, where in a cell you have a lot of, and I think we've talked about this a number of times, you have a lot of complexity in the cell. You have a lot of subsystems that you want to simulate. And so you would do that in a way that's sort of a unified model. I don't know if I'd define it as a foundation model, but it's a type of a large model that has a lot of parts to it. And so, foundation models are, of course, different. And I don't know, we talked about some definitions of foundation models. And, those are, again, another tool that you can use to get at, to sort of bring together a number of different subsystems or submodels and use them in different ways. And we've also talked, of course, about the, specialized large language models for research. So we talked about the Levin bot a long time ago, where, you train it on some literature, and you query the model, and you say, what is this? Is there a definition or, some hypothesis? And it gives you an answer that's very specific to that field. But it also has access to the larger world, so it doesn't just kind of give an answer that's kind of very specific to the field, because obviously it needs more to go on, to put it in a larger context. But so those are, a lot of the large language models now, you can run those on a home, on like a Mac Silicon, and it's a little tricky to get running, but you can run them, and so the portability of the models is getting there. Of course, you have to optimize them, and there are a lot of different ways to model something. So with a lot of the climate models or the foundation models, you might include a lot of different methodologies within them. And so, with respect to like the development of Bradenburg vehicles, we've used things like evolutionary programs. We've used things like Hebbian learning. We've used things like developmentally specific algorithms and other things that you can use. There's morphological computation techniques and things like that. That kind of, they're all sort of parts of that goal of trying to simulate. So you have to have a lot of different types of approaches that are unified. And so that's a challenge, really, to get that all to work well together. And so there's a lot to say there, but I want to show something interesting. If people are interested in evolutionary algorithms, there's this resource that I found this week. So this is like they're running this bibliography on GitHub. So this is where they have a bibliography on something called distributed evolutionary computation. It's from this evolutionary intelligence GitHub repository. It's a Chinese group, and they're doing this. They have this sort of bibliography that they're contributing to over time. Looks like some of the stubs are fairly old, but some are, kind of newer. And this is a still growing paper list of evolutionary computation, published in some rather all top tier and also EC focused journals and conferences. So this is where, they have the different conferences and journals, and they have articles in them on evolutionary programming, evolutionary computation. So this is a good resource if you're interested in evolutionary computation. It's something that, the group has had a long-standing interest in. We don't talk about it that much in the group meetings, but it's something that we work from, especially for development of Bradenburg vehicles. There are a lot of different areas of evolutionary computation. So, there's a lot of diversity. It's not just a simple evolutionary algorithm. There are a lot of different, like if you go to GECO, which is a conference where they talk about this, there are a lot of different techniques that they cover and a lot of different ways to optimize those algorithms and approaches. So it's very different actually from machine learning, the machine learning literature, because they're doing they're interested in similar ideas, but it's definitely something that isn't in mainstream machine learning as much. You don't usually see people get, deep into evolutionary algorithms. David Hough, of course, is an exception, but generally that's not a thing that people are doing.
Yeah, I think of Richard Watson too.
Oh yeah, Richard Watson.
I mean, just again, like as my wife's advisor, that was my first introduction to GECO and that kind of literature. Making those direct comparisons between evolution or evolution as learning.
Yeah.
Was really interesting to me.
Yeah. Amanda says. Go ahead.
No, I dropped the links in bioevolution.
Okay, yeah.
to emphasize that connection.
Okay, yeah, good. Amanda said evolutionary computation is something we could focus on for a few cybernetics reading group meetings. Yeah, there's some interesting readings we could come up with that kind of link. I don't know, maybe there are some that are more sort of related to cybernetics as practiced, or I somewhat know that literature. I could find something, but I think that's a good idea. And she has to go, so thank you for attending, Amanda.
But I think the great thing there with connection to cybernetics is of course these issues of teleology. And like what are you controlling?
Yeah.
You know, and the wonderful problem of nailing that down. But it does make me, well, just going back to very quickly the connection with developmental Bradenberg vehicles or developmental connectomes is this random matrix theory and looking at evolutions of you know what starts as random weights and you know how those get used computationally, which is, it's actually funny that we talked about LightOn because LightOn uses a lot of random matrix theory work, but they're using it again to actually do machine learning, you know.
Yeah.
So you know, there are ways, again, with kind of reinforcement, that you can start with random weights and you know, fashion something that is suitable for the task, you know.
Yeah.
which seems, you know, developmental Bradenberg.
Yeah. Yeah, if you look at the talk, I do talk about something like community activation in coding, which is an idea that kind of gets into that.
Yes, awesome.
Yeah.
Awesome.
So I'm going to finish up with, so if I go back to this developmental AI channel, and I recommend going through this because there's a lot of interest, especially if you're interested in AI, and, you know, it kind of goes beyond sort of what is in the mainstream of machine learning right now. People are trying to, you know, kind of apply developmentally inspired techniques to AI. So there's this couple, let's see, trying to find the one that we were talking about here. This one here, this cogmed.com article, the similarities between the learning of children and AI. So this is something Morgan posted, and this is an article on just kind of musings, I guess it says. And so they talk about a little bit about this. They kind of talk about machine learning. Then they talk about, you know, some of the things that we can use from development. So in this case, they're interested in Seymour Papert, Jean Piaget, and constructivism. So there's a lot of stuff here that kind of goes through what developmental psychology has contributed to what we know about the mind, what we know about cognition, and ultimately artificial intelligence. Although people haven't made that connection between Piaget and, you know, artificial intelligence. Papert tried to do this a long time ago. You know, he was recruited to the U.S. by Marvin Minsky. Seymour Papert was a member of the Artificial Intelligence Laboratory at MIT, and he's actually a co-author on the book Perceptrons. We've talked about perceptrons in the past, which are these small neural networks that sort of, you know, do pattern recognition. So actually, Seymour Papert is an interesting person because he has also a connection to agent-based modeling. And so he developed this idea of turtles and this language called Turtle Logo. And so if you're familiar with NetLogo, which is an agent-based modeling platform, NetLogo is based on Turtle Logo. That's why they call it NetLogo. It's a variant of Turtle Logo. And so Turtle Logo is this language that was developed for this. And this is basically, you know, it's a very simple programming language that, you know, children can interact with. So this is, so the description is here. In a console window, the children wrote commands to a turtle, which was sometimes on the screen, but was also made as a small robot turtle that ran around on the floor. By programming commands like forward and right, you moved or rotated the turtle. With the pen down command, the turtle's movement was recorded on the with a line on the screen. So the idea was to teach children math through, some mechanism that children, that's conducive to child learning. So it was more of this interaction between computers and children and how you can leverage their, learning through, and represent it at a computer. So the idea was that through programming, children would learn math the same way a child living in France learns French without taking any lessons or being aware that they are learning. So not as a language bath, but as a math bath. So you could actually use these turtles to teach concepts in math at a very high level of abstraction from mathematical language. It's this, idea of concepts and relationships and transformations. And so this is Mathland, which was Papert's expression of the fictional country, where children would learn to speak the language of mathematics with the help of programming. So this is an interesting article on Seymour Papert and the work being done at MIT on this topic. And so this is sort of how, we can use development to sort of look at, computing, look at AI. And so this is an interesting article on this. And, kind of thinking about how we might move to super intelligent AI or other forms of AI using learning, developmental learning. So that brings me to these papers that I'm going to talk about today. And so we talked about this infant learning area. And so we talked about the Linda Smith work. She published, I think this is a new News and Views so Linda Smith, of course, has been working for years on this sort of developmental learning and applying it to AI systems. And then we covered this paper by Vong et al., where they kind of take data from a single child and they use it to train an AI. So, Linda Smith, of course, is known for putting a GoPro camera on babies and filming what the infants see, in their learning process. And what was found from those data were that the learning process for infants and small children is much different than the type of learning that we use in training AI models from images today. So our training sets for AI models generally are like these sort of normally distributed models where we have, balanced representations of different classes. And what happens in developmental learning is you get these bunched sort of presentations around a single object where the infant will explore the object very intensely and then try to figure out the physics. And so it's a very different pattern of learning. So this is a new News and Views article, Can Lessons from Infants Solve the Problems of AI? And so this is, again, thinking about how development can influence sort of the way we build AI. So she's referring to this Vong paper, in which they do basically what she had done as well, but applied it more to training models. So writing in Science, Vong et al. Thrown down a challenge on behalf of humans by using 61 hours of one infant's real-life experiences to demonstrate the efficiency of a multimodal learning model. So the training data were captured by a head-mounted camera as multiple brief samples between the ages of 6 months and 25 months. So these were infants from 6 months to 25 months. They took, they had these cameras mounted on the head of the infant, and they took this first-person view of the world, and they would take that data and train an AI model. And it would result in different types of responses by the AI model. It's this developmental learning. And so they also linked this to vocabulary and language learning. So there was this linkage between these objects and language, and bringing those two together, as we recall from that paper. So you had video clips from the head camera, transcripts of adults speaking to the infant, and then this is supposed to be, sort of the beginnings of language learning and association between words and objects. So we have these developmental data. We have this model that we're going to train, and we're going to train it like we would train an infant, basically. So they're using this contrastive approach between vision and language. And so this is something that they use in machine learning called contrastive learning. It involves feeding pairs of training examples into an algorithm with a label indicating the similarity of two examples. Evidence that the two items are in the same category changes the model parameters to make those items more similar in the representational space of all pairings. So evidence to the contrary changes the model parameters that define the space to push items apart. So basically, if you see this object here, this red object, and you say that's a ball, it's, of course, we know it is a ball. So those things are associated again and again, and they become closer in that latent space, so that when that's referenced, the ball and the word ball are associated. If you called this a block sometimes, and this also a block, and you called this a ball, the association between this red object and a block would come together a little bit, but then get pushed apart by counterexamples, because you're also calling this a block, but you're calling this a ball, and you're calling this a block. And you can see how that process works. The more you repeat the idea that this is associated with ball, the closer the words and the objects become in this latent space. The more you call this gray object a block, the closer the words and the objects become in latent space, and you end up with these pairings that are learned. So that's the idea. So this is self-supervised learning. This is an example of where you don't necessarily need labels, or don't need to train it on these exemplars. You can just train it on an object, train it on a word, and you can get this sort of relational learning without really supervising it. So this is something that let's go through this figure here. This is the data collection from the Vong et al. Paper. This is where you have this external audio cue, where's your ball? The infant is exploring this space, so it needs to distinguish between a ball and a block. And so if the ball, the red object and the word ball are associated very tightly, then the infant will choose this red object. And if not, then they have to make a choice. And sometimes it's the wrong choice. But this is, pointing to like how infants learn, right? So they explore objects, they get a familiarity of the objects. And in doing this kind of exploration, they actually can do the generalization. They can do the sort of the learning from multiple perspectives. So instead of presenting a bunch of exemplars of balls, you just explore the ball in great detail. You learn all the detail, and then you learn the word for it, and then you can generalize not only to this red object, but other types of balls. And sometimes that leads to category error later, right? So if you had a spherical fruit, you might call that a ball. And of course, it's not a ball as some other linguistic label, which you learn later. So this is the kind of learning we want to enable. The trade-off between self-supervised learning, where you don't have to give a bunch of exemplars, and the sort of developmental learning where you learn the words for things gradually, but you learn like the object so well that you know how to generalize with respect to that label. The second example of reentrance in the brain, this just shows the different parts of the brain that are engaged. So external audio information engages language areas of the brain. External visual information, it engages visual cortex. There are these internal teaching signals, of course, which relate the two things. And then there are these learning influences that you see. And then Vong and colleagues, they model this reentrance. They reshape this reentrance model in a specific way. They actually associate these auditory cues with visual cues, but there's no feedback. So there's this learning of the object, there's this language, and then there's this recall where they have to pick the right object associated with that word. In fact, in the machine learning model, you're just associating the two words, the word and the object, and you're getting this kind of self-supervised learning. So this is reentrance is where you get feedback, where you get learning influences, and then in this machine learning model, there's no feedback. So this kind of goes through, she talks about human developmental science and how people are using wearable sensors and things like that. So we're collecting more data in this domain. So this is, going to be something that is going to inform a lot of, it's going to become useful to training machine learning models going forward, I think. And the more data we get, the more we're going to be able to do these types of studies. So that's from Linda Smith. And then there's this other paper from Brendan Lake, who's at Columbia. We've talked about Brendan Lake's work before, where, they did some work on developmental AI and training machine learning models. And this paper is from Nature Machine Intelligence. This one is learning high-level visual representations from a child's perspective without strong inductive biases. And so this paper is not, this actually, they're also using a head cam, but they're using it in a little bit different way. So the abstract reads, young children develop sophisticated internal models of the world based on their visual experience. 10 such models be learned from a child's visual experience without strong inductive biases. To investigate this, we train state-of-the-art neural networks on a realistic proxy of a child's visual experience. These are these GoPro cameras picking up data and giving us this naturalistic data that we can then use to train our models instead of training it from image data sets like we often do. And then without any explicit supervision or domain-specific inductive biases. So we don't want to use a supervised learning technique where we label all the images and give them specific, categories, and then the machine learning algorithm has to kind of figure out, is this object this thing that has a label, or is it like, is it a transformation of this thing that has a label attached to it, but it's not like, it's a label that's kind of learned and associated with it. So it's a little bit different way of doing this. So, but this also avoids inductive biases. So that's what they're getting at here. Specifically, we train both embedding models and generative models on 200 hours of headcam video from a single child collected over 2 years and comprehensively evaluate their performance in downstream tasks using variance reference models as yardsticks. So they're doing, in this paper, what the Vong paper did, and like what Linda Smith did, but they're doing this. They have 200 hours of headcam video from a single child over a 2-year period. So this is really, a deep sort of data set where they're exploring different parts of their world. They're getting this information, and they're not using auditory cues. They're just using the image, the naturalistic stream of information. On average, the best embedding models perform at a respectable 70% of a high-performance ImageNet trained model. So ImageNet, of course, uses these static images with labels, and it has to classify those images into a certain label or a certain category based on labels. This actually performs at 70% of what ImageNet would do. So that's pretty good given what we have here in terms of lack of sort of this overt supervision. And this is despite substantial differences in training data. So the training data sets are different in structure and also in having these categories sort of given to the model. They also learn broad semantic categories and object localization capabilities without explicit supervision. But they are less object-centric than models trained on all of ImageNet. So what this means is that you have these sort of broad semantic categories. So you can take a ball and you can look at a ball from different perspectives, maybe different types of ball, basketball, baseball, and you can basically get them because ball is very broad. It includes a lot of things. It includes a lot of detail. But you have these type of abilities, object localization as well, but you don't have models. The model of learning in this case is not as object centric as you get in ImageNet. So it's not based on, you might have like false positives, like where you have a spherical fruit that looks like a ball, that could be classified as a ball, a type ball. But balls generally, you're getting like baseballs, basketballs, other types of balls, without having this being reliant on specific labels. Generative models trained with the same data successfully extrapolate simple properties of partially masked objects. So it means if you, obscure some of the details of the objects that you present to the model, it can identify things. So a ball, if you explore a ball a lot, you get the sense of what it is. That generalizes then to this idea of if you mask, like maybe the surface of the ball or the color of the ball, you can still recognize it as a ball. So the model can successfully extrapolate simple properties like the rough outline, texture, color, orientation. So you have these aspects of the ball that, you don't have to have everything in one place. You can just say, does that look like a ball? Is it spherical? Or is it brown and spherical? That's, a ball. Or if it has a certain texture, that's a ball. So that, in that sense, these categories are very general. It can generalize, but sometimes it generalizes too well because it struggles with finer object details. So there are a lot of there's a lot of interplay between these naturalistic training sets, the way the object is explored and the information is extracted from the objects, and then how they're recalled in this way. So there are a lot of trade-offs you make with these kind of training sets in the same type of generative model. We replicate our experiments with 2 other children and find remarkably consistent results. So 2 other children, and we think of children as all learning the same, but actually, depending on the child, they might have, especially in these naturalistic data sets, they're going to present different types of maybe exploratory strategies and different learning techniques. So, but of course, in this case, they were able to find remarkably consistent results. Broadly useful high-level visual representations, which is what we're trying to build, are thus both robustly learnable from a sample of a child's visual experience and without strong inductive biases. So this paper kind of goes through, and they kind of show here where they have the SACAM data from 6 months to 32 months. So they're exploring objects, they're exploring them deeply, they're taking different perspectives on different objects in the world. They have these self-supervised embedded models, so they are able to create an embedding from these objects, taking the video and extracting an embedding from them. You also have self-supervised generative models, which can be encoded, and then there's a prediction made, and then there's an evaluation where there's an encoding of the object, there's a completion of the pattern, and then there's a decoding. So they can recognize larger patterns from smaller partial patterns. In the case of self-supervised embedding models, you get this linear evaluation, you get this object, and then it has to make a classification or it has to segment the features in the image. So you can do a number of things with these kind of models, and they perform fairly well. They perform at about 70% of what we get with ImageNet, which is actually pretty good because ImageNet has been refined, and that's kind of one of the gold standards for this area. So that's all I have for that. It looks like we lost a couple people, but thank you for attending. Himanshu had to go, and Adama had to go, and but I'll be posting this on YouTube, so we'll be able to see the entirety of the meeting, and Jesse as well. So, so any questions about that or any comments?
No, just to add that there's a great video of Michael Frank focused on the language. So like you've shown the issues about connecting language with what the child's seeing, and Michael Frank has more on language development, especially in the our age of big data, which kind of means large language models at this point, and but really interesting, and like Linda Smith has reference to the Child's Project. These are old. These projects go back a ways. But I just wanted to drop in something. I'm working with a professor in Irvine. Like we're both really interested in algebraic geometry and how that connects to data analysis. but also early math education, and going again back to Piaget, or at least my training with Piaget, where it was just like talking about what are the best ways to present this kind of material to young children. These advanced concepts to young children. Sorry, I have a young child who's not happy about breakfast right now.
Yeah.
But there's big controversy right now in California about math education, and a lot of people throwing around a lot of literature on it. But I think it's really interesting. I dropped something in about the algebra project, and certainly, I think it's one of the most important educational goals is to learn how to better present math. And it's nice to talk about Papert too, right?
Yeah.
And those it's like, it's not just about programming, it's about scientific thinking.
Yeah.
It's like, it gets sometimes called computational thinking, but I think it's also scientific thinking. And how that also relates to Piaget's work in as like children as little scientists.
Yeah.
and like, if you think about it in that kind of reinforcement learning context, or think about it in our sciencey way, we're trying to put children into more and more complex environments where they're figuring out these rules, and internalizing them, which allows them to then go on to understand more complex structures and more varied fields. Anyway, I just super interesting, but super relevant in terms of the algebra project tries to put it in context for how this is important for society.
Yeah, that's great. Well, thank you. Yeah, so that's good, and we should keep following up on that, because it looks like it's a very growing literature, and we want to be informed. Well, thank you for attending, and again, we'll be here next week, and keep in touch on Slack. So, thank you.
Take care.
Have a good week. Thank you. Bye.